Hi friends, welcome to this class. In last class we were discussing introduction to Redox Titration, right? In this class let us discuss few more things. So in last class I explained about cell. So each cell have two electrodes. One half cell 1 plus half cell 2. Total half cell. So two electrodes will be there. One I told as anode, other one I told as cathode. And also in cells also we have discussed two types. One is electrochemical cell, other one is electrolytic cell. These things also I have discussed in that chapter electrochemistry, right? Electrochemistry part 2. There I have discussed about these things also. Here electrochemical cell means chemical energy is converting into electric energy by spontaneous chemical reaction. Whereas in electrolytic reaction, this electrical energy is converting into chemical energy in the presence of some cell or batteries. So these are non-spontaneous. We have discussed everything, right? Here chemical to electric energy, the dry cells or the cells which we use in our watch, and also in microphone, the cell which we use in microphone, everything, these are where chemical energy is converted into electric energy and we can't recharge it, right? Some cells are rechargeable, primary cells, secondary cells, everything there we have discussed, right? So anode, cathode we discussed, and also in last class we discussed about galvanic cell. Galvanic cell is nothing but the arrangement of these metals, right, elements in form redox. And see here I did like this, Zn2 plus comma Zn from plus 2 to 0 oxidation means reduction. So reduction potential I increase, in the increasing order of reduction potential I arranged, isn't it? Fe2 plus comma Fe, like that I arranged. Then comes 2H plus comma H2, then comes Cu2 plus comma Cu, like that I arranged. These are the increasing order of their reduction potential. Those which falls below are good reducing agent, those which falls below will undergo reduction. Reduction means these are good oxidizing agent, right? And those which falls above this thing are good oxidation. They undergo oxidation because less reduction potential, it means more oxidation potential. So oxidation, that thing we discussed, right? And also this reduction potential of hydrogen 2H plus H2 at 0 degree, that Kelvin, at room temperature 25 degree, its reduction potential will be 0 voltage, right? And those which are having high reduction potential will act as reducing agent, and those which are having low reduction potential will act as oxidizing agent. These things we have discussed in electrochemical cell, right? See here I have got one example here. Let me see. Yeah, see here they have given like this, Ce4 plus 1 electron gives me Ce3 plus, and the reduction potential, see here, reduction from plus 4 oxidations to plus 3, there is reduction. So reduction potential they have given is 1.45 volt. And also for this one more compound they have given, Zn2 plus comma 2 electron, you will get 2 electron, and they have given zinc solid, and its reduction potential they have given it to be minus 0.76 volt. See here I told one which is having, see here it is also reduction, this is also reduction, and I told one which is having higher reduction potential will undergo reduction. So in this, if these two cells are combined, half cell, then this will undergo reduction like this, because its reduction potential is greater 1.45, whereas this is negative 0.76. so Ce4 plus gets 1 electron, undergo reduction like this to form Ce3 plus, right? So its E0 is 1.45 volt, whereas this will undergo oxidation. Oxidation state means I need to reverse it. Oxidation means from lower oxidation Zn0, it will convert into oxidation means Zn2 plus 2 electron, right? So its E0 is going to be since I see here Zn2 plus I counted ulta I made, no, so minus becomes plus 0.76 volt. So I can balance this equation by balancing electron. Here I need to multiply into 2, right, because 2 electrons are released here, it will take that 2 electron, so the net reaction will be 2 Ce4 plus gives me 2 Ce3, sorry, I need to write this also, no, plus Zn gives me 2 Ce3 plus Zn2 plus. This is a total reaction. If I want to calculate E naught of cell, how I will calculate? E naught of cathode minus E naught of anode. This thing we will do. E naught of cell is nothing but E naught of cathode minus E naught of anode. I told cathode where reduction occurs. So which one is undergoing reduction? This is undergoing reduction. So E naught of cathode they have given to be 1.45 volt minus E naught of anode. Anode it is undergoing reduction. Sorry, this anode means this zinc is undergoing oxidation. They have given reduction potential. To calculate this E naught of cell, we make use of only reduction potential. Whereas I did it ulta, right? So minus becomes plus. This is oxidation potential. E naught will be like Zn2 plus comma Zn means it is reduction potential. It is minus 0.76. If I do it ulta means E naught of Zn comma Zn2 plus. Here 2 plus 2 0. Reduction potential they have given like this. If I made it ulta Zn2 plus, it will become plus 0.76. That is, this is oxidation potential, whereas reduction potential. I am following the equation. E of cell is equal to E naught of cell is equal to E naught of cathode minus E naught of anode. Here both I need to use reduction potential only. I should not convert into oxidation potential, right? Only if I explained you how if we need to do ulta to write this cell reaction, right? So E naught of cell is nothing but E naught of cathode reduction potential minus E naught of anode reduction potential. Reduction potential is minus 0.76 volt. So 1.45 minus of minus plus 0.76. You calculate, it will be the E naught of cell. Those things I have explained in that electrochemical cell, right? So everything will be the same. So for hydrogen, the reduction potential is 0. So we take that as a reference for many of the elements, right? We take SHE, standard hydrogen electrode, which is 0 volt, will be taken as a reference. So this is about reduction potential, oxidation potential, and also I have explained about oxidizing agent, reducing agent, right? Oxidizing agent is a one which undergo reduction by themselves but make other oxidize, and reducing agent is one which undergo, right, oxidation by itself by making other reduce. That is reducing agent, right? See here, K2Cr2O7, KMnO4 are called oxidizing agent because they undergo reduction by themselves by making iron as oxidizing. Fe was converted to Fe2 plus, making other oxidized. But Fe2 plus is undergoing is called as reducing agent. These were called as oxidizing agent, whereas iron is called reducing agent because it is undergoing oxidation by themselves by making this one reduction. We can define both by from this to this also we can define, from this to this also we can define. Like we will tell now, if a glass is there half of water, we will tell the glass is halfly filled, we can tell, or glass is half empty, we can tell like that. We can define both oxidation reduction from one to another, right? And so I explained you everything. Let us discuss Nernst equation. Nernst equation also I have derived in that electrochemical cell, but then still also let us discuss little bit about Nernst equation. Nernst equation. Sorry. Nernst equation. What happens here? We know delta G is what? Minus NF E naught of cell, right? Minus NF E naught. E naught stands for standard condition, 25 degrees Celsius, 1 atmospheric pressure. If such things are there, standard condition, we get the electrode potential, that is standard electrode potential, that is E naught is equal to, we have RT upon RT ln K. This thing we have from this equation. E naught is what? E naught is equal to minus RT upon NF ln K. This is the standard. If we have other than 25 degree, then E will come into picture, which is not standard. E is equal to E naught minus RT upon NF ln K. What is K? K is like a equilibrium constant. How we will determine this everything, that thing we will discuss. This is the Nernst equation. E is equal to E naught. If I want to convert ln into log, what I will do? Ln Q is there. To convert into log Q, just it will be 2.303 into log Q. Right. Similarly here, E is equal to E naught minus 2.303 RT upon NF log. It becomes log K. Right. One more thing. R is a gas constant. Its value is known. T is temperature. If temperature we take to be 25 degrees Celsius, we convert into Kelvin. Right. 298 something Kelvin we will get. And F is Faraday constant. It is 96500 Coulomb. Right. If you substitute all this value at 25 degrees Celsius, at only 25 degrees Celsius, then it becomes E is equal to E naught. See here, if I substitute 2.303 into R value, if I substitute T value, if I substitute T means 25 degree, converted into Kelvin, 298 Kelvin, right? 298. N I don't know, F also I know, so I will get E is equal to E naught minus 0.0591 upon N log K. This is the Nernst equation at 25 degrees Celsius. Right, at 25 degrees Celsius. This is about Nernst equation. So let us see how to find the Nernst equation. What is about this K, everything we will discuss now. These things we have done in that electrochemistry, right? So let us see. See here, I was only talking about reduction potential, not oxidation potential, right? So see here, Fe2 plus is converting to Fe, right? It happens only when 2 electron it takes. So it is reduction from higher oxidation state to lower oxidation state. So reduction. For this, if I want to write the Nernst equation, E is equal to E naught minus at 25 degree it will be 0.0591. N is nothing but number of electrons it took. See here, it took 2 electrons to convert into Fe0. So N is nothing but 2 log K. K is, I told, like a equilibrium constant. That is nothing but concentration of Fe divided by concentration of Fe2 plus. Concentration of Fe is nothing but it is in a solid form, and also we know that concentration of any solid form won't change. Its concentration will be of any solid form will be always unity 1. So we will take it as 1. So this is for iron which is undergoing reduction, right? So the potential which I will get is called reduction potential, and this potential will be the standard reduction potential. That thing we will be knowing, right? So the potential which we got is reduction potential. Similarly for zinc also I can calculate Zn2 plus gets 2 electron converts into Zn. See here. Here what happens? E is equal to E naught minus 0.0591 divided by, since it is also getting 2 electron, so it is also 2 log concentration of Zn, which is solid, so it will be unity divided by Zn2 plus. So this is also reduction potential, this is also reduction potential. And we know that in galvanic series zinc comes first, the reduction potential of zinc comes first, followed by iron, right? So it will, since it is having more reduction potential, it undergo reduction, means cathode. Since it is having less reduction potential, it undergo oxidation and acts as anode. So E naught of cell is nothing but E naught of cathode reduction minus E naught of anode reduction potential only we need to write, right? E naught of cathode reduction potential minus E of anode reduction potential. So here cathode, which will act as cathode? Iron will act as cathode. So where is iron? It acts as cathode. Where is zinc? It acts as anode. So what happens? E of cell we get. This half cell, this is one half cell and this is another half cell. Total E of cell is equal to, let me write the reduction potential. Here I need to write like this, Zn 2 plus comma Zn. For this it is Fe 2 plus comma Fe. Since zinc is acting as anode, right? So I'll get Fe naught of Fe 2 plus comma Fe minus 0.0591 upon 2 log 1 upon concentration of Fe2 plus. Since it is E naught of cell is equal to E of cathode minus E of anode. So minus of anode is this one. So it minus of E naught of Zn 2 plus comma Zn. Why it is acting as anode? Because of its reduction potential. Minus 0.0591 upon 2 log 1 upon concentration of Zn 2 plus. Right? We came up to this. So next step will be, see here, just simplify. So E of cell is nothing but E of this much, this one, let me call it as E1, right? E1 and E2. E of cathode minus E1. E of cell is nothing but E1 minus E2. E1 minus E2 is nothing but, I will call it of E of cell. So it is E naught of Fe2 plus minus of E naught of Zn2 plus comma Zn. So let me call it by E naught of cell. This half cell minus of this half cell. So E naught of cell. This is also E1 for this, E2, E1 minus E2. Since cathode minus anode, so E1 minus E2 is nothing but E of cell. Right? Then minus 0.059, minus of minus, it becomes plus. So what happens? Let me write minus 0.0591 upon 2 1 upon concentration of Fe2 plus this one, because minus of minus is plus 0.0591 upon 2 1 upon concentration of Zn2 plus. Therefore E of cell is equal to E naught of cell minus 0.0591 upon 2. If I take minus of this common, then I am left with concentration of 1 upon Fe2 plus minus 1 upon Zn2 plus, right? If I take common 0.0591 upon 2, so it is nothing but I can write like this also, concentration of this, or since, oh sorry 0.0 log is there. So see here, so I am getting, so I took minus 0.0591 upon 2 common, so I left with log 1 upon Fe2 plus minus log 1 upon Zn2 plus. So log A minus log B is nothing but log A by B, right? So E of cell is equal to E naught of cell minus 0.0591 upon 2 log A minus log B, log A by B. So 1 upon Fe2 plus divided by 1 upon Zn2 plus. It is nothing but log of Zn2 plus divided by Fe2 plus. You got now this thing? It will be like 1 upon Fe2 plus divided by 1 upon Zn2 plus. So Zn2 plus comes above, Fe2 plus remains as it is. So it is log of this thing. Like this also we can do. Or one more smallest thing. That thing is simpler than this. What we do? See here. We know what we know. Zinc is undergoing oxidation. So write the cell reaction. Half cell reaction for this. Zinc is undergoing oxidation. So Zn2 plus 2 electron. Iron is undergoing reduction. Write the reduction. 2 plus 2 electron Fe. So cell reaction is Zn comma Fe2 plus gives Zn2 plus comma Fe. That is comma means plus Fe. This is the cell reaction. So E of cell, this is half cell, total cell. E of cell is equal to E naught. E naught of cell means if they have given reduction potential which will undergo cathode, that we need to do E naught of cathode minus E naught of anode. That will give you E naught of cell. E of cell is equal to E naught of cell minus 0.0591 upon n. In both the cases it is 2. So divide by 2 log. Right. See here. From here you can write log K. K is nothing but its concentration. The concentration of solid form won't change. So let us rub this only. K means product, that is Zn2 plus divided by reactant. So it is Fe2 plus. So E of cell is equal to E naught of cell. It is for cell E naught of cell minus 0.0591 upon 2 log Zn2 plus comma Fe2 plus. Like this also we can do, or we can do separately. I will take first this, second this, E naught of cathode minus anode I will do, then I will get this thing, and I will get finally this thing. Both will be the same. See here, E of cell is equal to E naught minus 0.0591 log Zn2 plus comma Fe2 plus. Same thing. In next class, let me take one example and I will do the same thing, and we will discuss about equilibrium constant in the redox titration, right? Such things we will do and we will go further, right? Thank you.